Good evening, students. Today we are going to learn about the Rutherford model of atom. Students, regarding the structure of atom or atomic structure, different atomic models are given. These models tells how the subatomic particles are arranged inside the atom. The very first model was J.J. Thomson model, where proton was considered as a sphere and electron was put inside it. That we had learned earlier. So in this J.J. Thomson model, there were a lot of limitations. This J.J. Thomson model was not able to explain various observations. So that's why the another model was given by Rutherford based on their alpha particle scattering experiment. So based on this alpha particle scattering experiment, Rutherford has given the model that proton is present at the center, but electron is revolving around the center. It was the Rutherford model. The size of the nucleus where proton is present is very, very small as compared to total size of the atom. But this model was also not able to satisfy the observation of physics, like when one particle or one of the charged particle is moving around the other charged particle, it will lose their energy. If they are oppositely charged, they will merge together or collapse. If they are like charge, means both are positive charge, then they will repel each other and there will be no force of attraction or no fixed relation or fixed size between them. So that was not explained by this Rutherford. So to overcome these two limitations, Niels Bohr has given this model in 1920. For that, he was conferred with Nobel Prize in 1922. So what was his model? That we are going to learn. So very first thing, this Bohr model or Niels Bohr model overcomes the limitations of Rutherford model, where Rutherford model was based on consideration that electron is just moving around the nucleus in a circular path. This Bohr model has given the explanation that there are certain fixed paths in which electrons can move around the nucleus, not all the paths. And these fixed paths have a fixed energy where energy is not radiated or energy of electron is not lost. That's why the atom is stable. Means it was just improvement or improved version of Rutherford model. Another important thing the Bohr has given was, if there is a fixed path around the nucleus, then this path can contain how many electrons? That was also given by this Bohr model or through the Bohr-Bury scheme. So this distribution of electron in different paths is called as electronic configuration. So two things we have to understand in this Bohr model. Very first is, what is this Bohr model and how this have overcome the drawback or limitations of Rutherford. Another, how is the distribution of electrons over the fixed path. So student, what this model was, a student, according to Niels Bohr, whatever the model given by Rutherford is true or partly true, but whatever the Rutherford has left untouched, that the electrons are revolving around the nucleus, he had given the modified version of that. A student, we had learned that if we consider this as an atom, means this is the size of atom, then the center of this atom contain protons, and this center have maximum density and entire mass is concentrated. So this central region where entire mass is concentrated and proton is present is called nucleus. So this we had already learned. So this portion which contains the proton was called as nucleus. Students, till Bohr, which was in 1920 or 22, inside the nucleus only proton was considered, but in 1932 another subatomic particle present in the nucleus was discovered, that was neutron. Okay, so this nucleus remains unchanged, but just one more particle was discovered. So this center region called as nucleus. So this is our nucleus. It is our nucleus. So this central region is our nucleus, as given by Rutherford. It's true. Bohr have also adopted the same thing. Yes. At the center of the entire atom, nucleus is present, and nucleus contains proton. It contains proton. But later on, with the discovery of neutron, it was also found that it contains another subatomic particle called neutron. This Bohr model was given in 1922, means accepted, but this another subatomic particle neutron is present here. This was adopted in 1932 when neutron was discovered by James Chadwick. Okay, the model remains unchanged. There was no variation in this model even after the discovery of neutron. So according to Bohr, there is a nucleus also which is at the center, which contains entire mass. But the feature Bohr have added was that whatever this path given by the Rutherford, he suggested that this path is always fixed. Means there is always a fixed path over which the electrons can revolve. Means these are the fixed path over which electrons can revolve. A student, here it is too important to understand what do we mean by this fixed path over which the electrons can revolve. A student, in this case, we have to keep in mind while we are saying the fixed path, it means how this path, circular path is identified. Say if I am saying this is a point from which there is a fixed path, how this fixed path can be identified? With the help of the radius from this fixed path. Okay, it simply means this circular path have fixed radius. So if this is the center, C or O, inner radius let me call as R1, the outer radius let me call this as R2. Okay, so he suggested that these paths are fixed, means they have the fixed radius from the center or nucleus on which the electrons can revolve. So fixed path means a fixed or constant radius of circular orbit, of circular path. So this fixed radius is always measured from the center, and the center is what? Nucleus. So from the nucleus. So this fixed radius for the circular path on which electron or electrons revolves. It's simply. Another thing is suggested was that while this path is fixed, it means in this fixed path, the electron will have the fixed energy. So this implies the electrons in one particular path have fixed energy. It will not lose or gain their energy in particular path. Means this particular is our fixed path, have fixed energy. Means this electron can neither lose energy or nor gain energy as long as it is moving over this path. So their energy are fixed. Therefore, these circular path were called as fixed energy cell or fixed orbit. So they are called as fixed or constant energy cell. Cell is what? Just a hollow path or orbit. Means these circular paths were called as orbit. Okay, student? It was this proposition. These were the additional thing over the Rutherford. Rutherford didn't give the idea of constant energy cell, that is constant or fixed energy cell. So this fixed energy cell are nothing but this is the particular circular path around the nucleus inside the atom where the electrons can move. So electrons can move over this path only. Can move. What is the move? It is the circular path. So also written as revolves over only this fixed path, this fixed orbit. And these fixed orbit were named. So orbits were named as 1, 2, 3, 4, as 1, 2, 3, 4, or this 1, 2, 3, 4 is also called as K, L, M, N, O, like this, starting from or near to the nucleus. From means it is not exactly touching the nucleus, so it is near to the nucleus. Okay, student. So it is all about the concept of Bohr model, who has suggested that there is fixed path. Once again, let us understand this, student. So let me rewrite over this. If we consider an atom of this much shape, are we getting? This is the atom. okay, or outer boundary of the atom. It is this much. So this is our atom. So this is the atom. Atom is the outer boundary, okay, or the maximum size. Atom are spherical in shape. Then inside this atom, the center region is called as nucleus. So whatever the center region is here, the central region is called as nucleus.
Yes.
This was discovered by Rutherford. So this Rutherford model, whatever up to this much is as it is. The additional thing Rutherford had given was these electrons are revolving over this. So electrons are just revolving over this path. Okay. Rutherford didn't tell that, say if we compare with the Rutherford, then Rutherford has also given this much thing. So this is the nucleus, this is the outer boundary. Rutherford had given that inside this nucleus there is proton and electrons are just revolving around it. But in which path it will revolve, from where to where it will revolve, it was not given. He had just given that electrons are free to revolve from even just near to the nucleus to the outer boundary. So this much where the space available. So outside nucleus where electrons are free to revolve. So in this entire space, electrons can revolve. No fixed path was given by Rutherford. Okay, this was the main drawback. So Bohr have adopted that whatever this extra or outer region that Rutherford have considered, in this region there are only fixed path. It is not the entire space over which or in which these electrons can move, but there are only certain path. Means no fixed path in Rutherford model. But this fixed path, are you getting? So this fixed path, the concept of fixed circular path over which the electron can revolve, this was the additional feature given. And he postulated that these fixed paths are having fixed energy over which if the electron is going to revolve, it will not lose the energy. Because in Rutherford model, the question was that if the electron is moving around this positive charge nucleus, then it will lose energy. And while losing the energy, it will collapse. The atom will not be stable. This was the main drawback. So considering this, he had just postulated that no, there are only certain paths over which the electrons can revolve. How many paths are there? That is decided by number of electrons. So write the next point. So number of path or circular orbit around nucleus depends on number of electrons in that atom. Means this number of path over which the electron can move is not fixed. Say if there is up to 2 electrons, then it can have only one path. Example.
Sir, somebody wants to join.
Example, if the atom having up to 2 electrons, then only one path is needed. Means that atom, so what they are up to 2 electron, it is hydrogen and helium. So they have just only one path. Means if we draw the hydrogen have one proton, one electron, so proton or positive charge will present here, and over this there will be only one path in which one electron will revolve. It's enough. For helium also, the 2 protons will present at their nucleus or inside their nucleus, and over the single path the 2 electrons will revolve. But coming to means one path is enough. But if you are considering up to 10 electrons, then 2 paths are required. How is that? All these are obtained by considering their electronic configurations. Okay, or distribution of electron in this path is called electronic configuration. Up to 10 electrons, only 2 path is required. So 2 path is required. Means what if we are considering the lithium? The first one was hydrogen, this is for helium. But if you are considering the lithium will have 3 proton in their nucleus, and they need 3 electrons to neutralize it. For accommodating these 3 electrons, they need 2 paths. The first path, this one, the other path after this. So 2 electrons will revolve over this, and the 3rd electron will go in the next orbit. The name of this path were given by either number. You may consider this is n equals to 1, or path. Student, this is nucleus, so you just forget this nucleus. You need not worry about this nucleus. So whatever the proton return, they are the nucleus. Whatever the circular or the circle or concentric circle drawn, they are the path. So this is n equals to 1, first path. This is n equals to 2, second path. It was also given or denoted, means these paths were also denoted in term of their letter, than this is K, this is L. If one more will come after this second path, it will be denoted by n equals to 3 or M. So this thing we will see. Okay, student. So this was all about Bohr's model. So what Bohr have given? Bohr have given the concept of fixed energy level. So the concept of fixed energy level, this is suggested by Bohr. So this is called concept of fixed energy level or shell or orbit, mean the same thing. So this was the fixed energy cell or orbit. What these are? They simply mean, if you are considering the fixed path, how the fixed path means fixed distance from the nucleus, then this concept can hold good. It was this one. So now I am going to write what are the salient feature, how is the electron distribution. So how much electron can present in particular path, that distribution of electron in particular path is called as electronic configuration. So this electronic configuration in this fixed path we will also learn. Their numbering or name is like this one, starting from the nucleus or near to the nucleus. It can be 1, 2, 3, 4. The distribution of electron in this cell is called as electronic configuration. And write one more thing here itself. Distribution, how much orbit or circular path will be there, that depends on the electron. But this distribution of these electrons in their orbit is called as electronic configuration. So the concept of electronic configuration is very helpful in understanding why the sodium is able to 1+, why magnesium is able to form Mg2+. Okay, all these things. So the concept of electronic configuration was very important. With this electronic configuration, all the unanswered or questions were answered. So that's why this is the most successful model which was able to explain all the queries of the scientist and all the observations. But later on, certain limitations are also there with this model. And nowadays, orbital model or molecular model is given. That concept we will learn in class 11th and 12th. So we are going to write all these things point by point. Okay, student, I had explained everything. The very first is the concept of fixed path around the nucleus is given, in which the electrons can revolve. These electrons can revolve in this particular path only. Okay, while revolving over this particular path, it always have the fixed energy. So that's why it is also called as constant energy cell or constant orbit model. But how many orbit, how much electron will present in particular path, that is decided by its electronic configuration. Therefore, this electronic configuration, the rule was given by Bohr along with another scientist called Bohr. So it is called as Bohr-Bohr scheme. We will learn later. This electronic configuration follow the formula 2na square. Whatever this n we are considering, say this n value is 1, 2, 3, 4 or KLMN. So for k, n equals to 1, that n can be placed here. So it becomes 2. If we are placing n equals to 2, then 2 square is 4 into 2, 8. So second orbit can accommodate 8. So this, how much electrons can be accommodated in particular orbit is called as electronic configuration. So these are the things that we are going to finish today. Okay, student? So now let us go, or let us write all these things. I have explained everything. I'm just now going to write this thing point by point. Okay, students? So write on the model or salient feature of the model. Or salient postulate of this model. So write salient or important feature or postulates of Bohr's model. Means what was the Bohr model? If you have to write point by point, those things I am enumerating of Bohr's model. The very first postulate or very first statement what the Bohr had given, only there are certain special orbit or circular path over which the electrons are able to revolve. So electron cannot revolve in entire space outside the nucleus, but there are certain circular path over which the electrons are revolved. They are called as orbit. Right? There are certain means fixed, okay? Certain or fixed circular path around the nucleus over which means this path is even inside the atom, but it is outside the nucleus. Around the nucleus over which electrons can revolve. Okay, so this certain circular path or this fixed circular path around the nucleus, this fixed circular path around the nucleus was called as orbit, over which the electrons can revolve, is called orbit. Okay, so the concept of orbit was given by Niels Bohr. We have to keep in mind, just for a note, these what this orbit are. Orbit are the circular path around nucleus which is outside the nucleus, but it is even inside the atom. So over this path only means on this circular path electrons can revolve. Students, means electron cannot revolve as it wishes, but only there are certain path over which electrons can revolve. It was this one. The other thing, like nucleus and size of atom, size of nucleus, all those things as given by Rutherford was also adopted. Means what? If we are considering this as the entire atom, as the circle, then at the center there is nucleus which contains the proton, and in between this there are certain fixed path. So this fixed path over which the electron can revolve. So these are the orbit. A student, these orbit are identified with respect to the fixed radius from their center or from their nucleus. You may call this as R1 and this radius as your R2. Then keep in mind, this R1 is fixed, means the electron can revolve only over this path. This R2 is also fixed. Even there could be 3 orbit or 4 orbit, that depends on the number of electrons. Means the electron cannot move at any arbitrary path. That is, electrons can move only on these circles and cannot move on any circular path, any possible circular path inside the atom, which is outside the nucleus but inside the atom. So this was as per the Rutherford. So as per Rutherford, only circular path is there. On any circular path, the electron can move. But Rutherford have not given the concept of fixed path. But this Bohr have given the concept of fixed path. Okay. So this circular path inside the atom as given or as suggested by Rutherford model. Okay, this was the difference from the Rutherford. Are you getting a student? So it is very important to understand. Otherwise, the students are not understanding what are the main or key differences, and they are always getting confused between this Rutherford model and Bohr model. A student, the feature like nucleus, size of nucleus, and this circular path or the spherical shape of atom, and proton present in nucleus and electrons are revolving, those things are adopted by Rutherford, by the Niels Bohr as suggested by Rutherford. In that there is no any difference. So student, the first thing is there are only certain path over which the electron will revolve. So only certain special orbit known as discrete orbit. See, these are not the continuous, these are the fixed, means they have only fixed or certain path. So therefore, these orbits are also called as discrete orbit. So right, that is only certain spatial, certain fixed or a spatial orbit. Student, this orbit always means our this circular orbit known as discrete, means it is a fixed one or different, not a continuous one. Discrete orbits were taken. Orbits of electrons. So the concept of discrete orbit of electrons was given by Bohr model. So these discrete orbits of electrons are allowed inside the atom. How much is this radius, or what is the value of this radius, you will learn in higher standard. So you have to just understand there are only fixed path or certain path over which the electrons can revolve. So these fixed path were called as discrete orbit of electrons. Okay, this was the very first concept. Another notable feature given was that regarding the loss of energy of electron, when one charge move around the other charge, it loses energy. Regarding that, Niels Bohr had given their second postulate. It was this one: while revolving in discrete orbit, the electrons are neither gaining nor losing any energy. Okay, so right, while right, student, while electrons revolving over the discrete orbit or fixed energy cell, either discrete orbit or fixed orbit is written, or in place of orbit sometimes cell word is also used. So while electron revolve or while revolving over this discrete orbit, they are neither losing nor gaining any energy. Okay, so while revolving over these discrete orbits, it do not radiates energy. It means what is this? It, this electron. So they
Electron.
are, yes, they are do not, or they are not radiating energy. So therefore, there is no loss or gain of energy of electron. So electron will continue to revolve in that orbit and the structure of atom is stable. So right, therefore electron or electrons will not lose, or it may be the gain, not lose their energy and continue to move at fixed distance, move at this fixed distance. So while the electron is moving at fixed distance, the size of atom remains unchanged. So this implies the atom is stable, and no collapse or change in size of atom, or change in size of atom. So these were the two important postulates given by the Bohr. To describe this, different cells were given different name. So what they are, we have to go for that. So second postulate is like that: while electron revolving in discrete energy, they do not radiate energy. As a result, they will continue to move at fixed distance and the atom is stable. Okay, this way the size of atom will remain as it is. The third point is regarding these orbits. Okay, so these orbits are numbered from near to the nucleus and moving outward. So right, these discrete or fixed orbits are numbered or named, you may call, may write, mean the same thing. Named as n is equals to 1 or 2 or 3, means the specific one will be there, 4, 5, like this one, or as per their name, this is in numbering 1, 2, 3, and if we consider name, then name is given as K or L or M. Number corresponds to this one and name corresponds to the K cell, L cell, M cell, N, and so on. Means for n equals to 1, it is the K cell, n equals to 2, it is the L cell, n equals to 3, it is the M cell, and n equals to 4, it is the N cell. Okay, so these discrete orbits are numbered or named, so starting from near to the nucleus, starting from near to the nucleus. Understand the student? This means if we are considering an atom of this much size, student, let me consider this as the nucleus and the atom of this much size. Sorry. So consider this as the atom. Still not very much circular. Let me try once more. Let us consider this is the atom. It simply means this dark region will contain the proton, which is the positive charge. Now, after this positive charge, means after this nucleus, but inside the outer boundary of atom, there are fixed path. Let us consider this is the first path possible for electron to revolve. So this first path is numbered as n equals to 1 by numbering, or this may be called as K cell. Means if n means number is equals to 1, it is called as K shell or K orbit. Okay, student? So this is the very first orbit which is nearest to nucleus. So this is the nearest to nucleus. And the orbit which is near to the nucleus have minimum energy. Okay, this was the another postulate that we will also write later. So this have also means this have which is near to the nucleus, so it have minimum energy. Get it? So these discrete orbit are numbered as n equals to 1, 2, 3, 4 or named as K, L, M, N starting from near to the nucleus, where energy also increases. As we move away from the nucleus. So increases as we move outward. It is this one. Example here we have taken if n equals to 1 means that will be named as this n equals to 1 student here. In numbering we have taken this n equals to 1, so you are considering 1, it corresponds to your K cell. Get it? If you are considering n equals to 2, it means it corresponds to L cell. So we shall write, if we are taking n equals to 2, it will represent which cell? L cell.
L.
Good. If n equals to 3, what will be the name for this?
M.
M cell.
Very good. M cell. If n equals to 4, it is called as N cell. This much is enough for you. So considering the energy level, how is that? The energy is continuously increasing. So energy as per energy, this K have lesser energy than L, than M, than N. And they always have fixed, means K have only certain fixed amount of energy. Whatever the electron present in K cell, that possesses the kinetic energy as well as the potential energy. So the total energy is always fixed. Similarly, for the electron present in L cell, it also have the fixed energy. The energy possessed by electron in L cell will be higher than the energy possessed by electron in K cell. Okay, so this is the order of their energy, but also fixed one. So in an atom, how different cell can be drawn? So from the nucleus, the nearest one is numbered as 1. The next, if we want to write, what will be the name to this? It will be our L cell. Okay, student? The next one, if we want to take the next one, it will inside this. So it is our M cell. Yes. So students, this thing we have to keep in mind. Or while we are numbering, we should be careful. What is the order? So whether you write as L cell or n equals to 2 mean the same thing. Or M cell or n equals to 3 mean the same thing. Are we getting this much? So this was about the discrete energy cell. What these discrete energy orbits are and how they are, I have drawn this. Okay. Now this discrete energy orbit can contain fixed number of electrons. Okay. So these orbit or cells are represented by letter K, L, M, N or the number n equals to 1, 2, 3, 4 from nucleus to outward. Hence energy also increases. This is very important. Means as we move away from the nucleus, we are moving outward. The numbering also increases and their energy also increases. This is very important. Now, how much electron can present in this particular orbit? That is given by your electronic configuration. So these were the 3 important postulates that we have to keep in mind. Now let us go for distribution of these electrons. A student, we can see our book also. So in our book, we can see how is this model drawn. It is like this one. See, this is the model taken from the or representation for the Bohr model. So these orbits are also called as energy level. So whether we are calling this as orbit or energy level mean the same because they always have fixed energy. So considering the fixed energy, it is also called as energy cell. So let us write it here. So this is our Bohr model, where this nucleus, it will contain nuclear material like proton. So proton will present here. These are fixed cell. These are also called as energy level or energy cell or orbits mean the same thing. Orbit simply means the path, but this path have fixed energy. So therefore it is also named in term of their energy as energy level, but both mean the same thing. Students, and over these orbits, these will contain what? Which material it will contain? Electrons, students.
Electrons.
Yes, electrons are negatively charged. These protons are positively charged. So in symbol form, it is denoted as P plus. This is as E minus. More than one is possible there than electrons. Okay, it is this one. So this is the Bohr model, or in better way, after discovery of neutron in 1932, this proton as well as the neutron was included here. Okay, so contain proton up to this much was up to 1932, but and neutron was discovered. Neutron is neutral, do not possess any charge. So this was discovered since 1932 by James Chadwick. So we shall understand what is this electron. This we will also understand. Student, now the next one is, these are the orbits. It means what? Whatever the outer orbit is being represented, this outermost orbit that you are considering, this outermost orbit itself, it will represent the size of atom. Okay, students? So this corresponds to the, means this outer one corresponds to the size of atom. If one is asking what is the size of atom, then whatever the outer orbit that you can draw, that is self represent the size of atom. So this is the outer orbit. Okay, this is the outer boundary, means this is the size of atom, and nucleus just the black one. Are we getting? Even at the outermost boundary, the orbit itself is forming the outermost boundary. That's why it gives different size to different atoms. More detail we will learn in our next year and in next chapter. Now let us go for how these electrons are distributed in these orbits. So write that one, students, also. Write on the fourth point. Fixed number of electrons or electrons are distributed to different orbits, okay, or different cells. How this distribution, in which it will go, for that a rule is given. So electrons are distributed to different orbits, starting from which one? Anything try to attain the minimum energy state, starting from n is equals to 1. Okay, means the lowest energy level. That is lowest energy level, or the orbit near to the nucleus than outward. If more electrons are there, if more electrons are there. This was the rule. So how these electrons are distributed? The distribution of electron in different orbit is called electronic configuration. So write that. Distribution of electrons in different orbit, or energy cell, whatever the term you want to use, that doesn't make any difference. Okay, energy cell around the nucleus inside an atom is called electronic configuration. Electronic configuration. Okay, student? So what is this electronic configuration? That is the next step we have to understand. Along with this Bohr, the another scientist called Bury, collectively they have given the rule for distributing electrons in this orbit. So it is called as Bohr-Bury scheme. Okay, student? So let us go for that. What is this Bohr-Bury scheme and how is the distribution of electrons in different orbits? That we will see. The structure we will draw later. So right, electronic configuration. Or the distribution of electron in different orbit called electronic configuration given by Bohr. Along with the Bohr, another scientist was there who have worked with the distribution of these electron, so called Bohr and Bury. So write this as Bohr-Bury scheme, means the rule. So what is this electronic configuration? So according to this Bohr-Bury scheme, the electron start filling from the lower energy state to the higher energy state. So let us start that electronic configuration, or we will go for distribution later. What is the electronic configuration? Before that, we shall understand about the neutron. What is this neutron? How it was discovered? Those things. Of an atom. Okay, student. So this electronic configuration is nothing but distribution of electrons in different energy cell. Energy shell or different orbit. What this energy cell? The same thing that we have learned above. Okay. So what this rules tells that electrons start filling in an atom from the lowest energy. Means from the K cell it will start. If more electron will be there, then it will go to the higher orbit. So electron filling in orbit or orbits starts from the lowest energy shell. What is the lowest energy cell? It is our K cell. That is
N is equal to 1.
yes. That is from N is equals to 1 or K shell. So if access, then it will go to L cell. Again, if it is access, then it will go to M cell. And in next we will write that this K cell can contain up to 2 electrons. Means if there is 1 electron or 2 electron in an atom, then it will remain in K cell. If more than 2 is there, then the electron after the 2 electron will go to this one, the third or fourth electrons. they will go in this one. But this L cell, like this K cell, which can contain 2 electrons, it can contain up to 8 electrons. So these 8 electrons are after the 2 electron present in K cell. So this is after 2 electrons in K cell. If 2 electrons are already present in K cell and third electron, then it will go in L cell. How is that? For that there is another rule, we will see. Means if we have the 9 electrons, then out of this, first you have to put the 2 electrons where in K cell, then how much is left? The leftover is 9 minus 2 is 7. Okay?
7.
7 can go in your L cell. Okay? If there is 10 electron, then still this hold good. The 2 in K cell and then 8 in L cell. But if you have 11 electrons, then 2 in this K cell, up to 8 it can go, means the next 8 it can go in L cell, and whatever one remaining, because 11 minus 2 which have gone to K cell minus next 8 means total 10 have already been distributed. The remaining 11th electron means 1 electron will go in M cell. So how is this? Why it contains 2? The next cell contains 8 electrons. For this, he had given another rule called 2n square. Okay, student? So why this K contain 2, L contain 8, and M, though it can contain 18 electrons, the next 18, are you getting no? Not starting from 0 to 18. After giving 2 to K, next 8 to L means 10 is over. After that 10, whatever the 11th which is coming here, it is going to your M cell. Are you getting? This way the distribution will continue. So which cell will contain how much electron? For that, this second rule is given. So let us go for that one. Write down the rule number 2. The maximum number of electrons present in a shell is given by the formula, or must follow the formula, is given by formula 2n square, where n is our cell number or orbit number, where n is your orbit or shell number. Okay, it is like this one. Means if we are considering a cell or orbit may be represented by n equals to 1. This implies what it represents? K shell it is representing, or shell. Then how much electron this K cell can contain? So maximum electrons the shell can contain, or the orbit can contain. So I'm going to write this in the tabular form. So A, for this K cell, we have to follow which rule? So maximum electron it can contain for K cell, it must follow 2 into 1 square It becomes how much? 2 into 1. It is the 2 electrons. This is given by 2n square. It is the formula. They simply mean the K cell can contain maximum 2 electrons. Students, here we have to understand this is the maximum electrons content. Sorry, it was not saved. So let us calculate it. This is given by 2n square. So for this K cell, by formula 2 into 1 square become 2. So this implies K shell can contain maximum 2 electrons. Means up to 2 electron if the atom have, it will remain in the K cell. If more than 2, then after filling this K cell, it will go to L cell. Say n is equals to 2. This is our L cell. How much electron it can contain? Substitute 2n square, 2 into 2 square, 2 into 2 square is 4. So 8. This number 8 tells that L cell can contain maximum 8 electrons. But note that these 8 are the next electron after K cell. So these electrons will filled only when K shell is already filled. Okay, if the K cell is filled, then only the next electron will come in this. That is electron after the 2, after K cell, that is next to 2. Okay, next to 2 means after 2. The next 8 electrons can fill in L cell. L cell. Okay, it was this. If we are further going down, then take n is equals to 3. This implies M cell. So 2 into 3 square. So it becomes 2 into 9, 18. So this implies M shell can accommodate or contain maximum 18 electrons. It is this one. But student, again the point that these 18 electrons will come only when both this K and L cell are filled, then only. But there is another important point. These 18 electrons can be contained only if the outermost orbit have already 8 electrons. If this M cell is acting as outermost orbit, then it cannot have more than 8 electrons. That is the other rule. So provided right here the outermost orbit contain 8 electrons. What do we mean by this? Outermost orbit contain 8 electrons. That we will see later. We will understand this. This is very vital. For that, there is another rule called octet rule. But let us enumerate quickly this rule. Then that rule we will write. If n is equals to 4, this implies n cell. What is the maximum electron it can contain? 4 square, 2 into 16. So this 2 into 16 is our 32. So this n cell can accommodate, so maximum possible, these are the maximum possible electrons in n cell can be 32. But a student, here again, provided the octet rule. The octet rule. That is, outermost orbit can contain maximum 8 electrons. If this itself is acting at outermost orbit, then it cannot accommodate 32 electrons. So whatever we had written here. So provided octet rule, that is outermost orbit contain maximum 8 electrons. This is to be followed. Means if it is outermost, say if here, even for the m we can also write, if m is outermost, then it can accommodate maximum 8 electrons only. It cannot accommodate 18 electron. So here provided if m is outermost orbit, then maximum content, maximum electron in it, means even maximum electron in m can be 8 only, means up to 8. More than 8, again it have to go for the next. The same thing here also, if n is outermost, then n can have maximum 8 electrons. So this can accommodate 32 only if it is not the outermost. Getting no? So these are the important points that we have to keep in mind. The formula followed for accommodating the electron or maximum possible electron is given by 2n square. Yes, by this formula, the K cell can contain maximum 2 electrons. The L cell can contain maximum 8 electrons. Up to this much, there is no issues. But for coming to M cell, it can have maximum, means it can accommodate 18. But, means here provided is written, or but, if it is outermost, then it can have only 8 electrons. Then we cannot put 18 in this. Are you getting a student? It is very important. Say even for N cell also, the maximum capacity is 32. But even if itself is outermost, then it can have up to 8 electrons only. So this provided condition was given by the Bohr in a form of rule called as octet rule. So write down the third point or third rule, which is very important. So the maximum number of electrons that can be accommodated in any outermost orbit, whether it is K cell or L cell or M cell, okay, no, it can be 8 only. So right, the maximum number of electrons that can be accommodated. Accommodated means that can be contained or present. Accommodated in the outermost orbit how much is 8.
8.
Yes, means irrespective of which kind of orbit, the outermost orbit will always have maximum 8 electron. Okay, means that is even if, so right, that is even if say up to L cell no issues because have the 8 tendency, but if even if M or N cell is outermost, then it cannot have more than 8 electrons. Are you getting a student? Though for M cell, how much it can accommodate? Though it have maximum accommodating capacity or maximum capacity for M it is how much? Maximum capacity is 18.
18.
Yes. And 32 for N. Though it have this much capacity, but it can accommodate maximum 8 if it is the outer one. If it is coming as the inner one, then they can accommodate 18 or 32. This thing you will learn in higher standard. So this rule is very important. Maximum number of electron in outermost orbit is always 8, irrespective of even if it is M or N cell, still it can accommodate maximum 8 one. Okay, by this we will understand how the calcium can have the distribution, calcium and other one. So this was all about electrons are not accommodated in given cell unless or until the inner cell are filled. Okay, so that we have already explained here, but let me write that rule also. So even whatever the first rule that we have taken, it is in the order of increasing. Electron filling is always in the order of increasing energy level. Okay, so starts from the lowest energy level and continue to increase. So right, the next postulate or the fourth postulate, it is the last one. Electrons are not filled or accommodated in a given cell Means if we are going to directly M cell and we want to put the 8 electron for oxygen, we cannot put. First you have to go for K cell, then L cell. If both of these are exhausted or filled, then it can go to M cell. Okay, student? So electrons are not accommodated in a given cell unless the inner cell are filled completely. Unless the inner shells are filled. This is the rule. That is, start filling or distributing mean the same thing, or distributing electrons from K then to L then to M, so on. Okay, okay, student, these are the rules that need to be followed. So with this, if we consider one example, a student, here we have learned that, say the K is there, maximum capacity is 2. M is there, the maximum capacity is 8. Sorry, L is there, then we have to go for M. Then M is there, the maximum capacity is 18. N is there, maximum capacity is 32. So these things means 18 and 32. If this M is outer one, then it have maximum capacity 8 and 8. Okay. So this is provided if it is outer one, outermost. So this capacity get changed. If M is the outer one, then it will be 8. If N is outer one, means M is completely filled, then maximum in N it can be 8. It is like this. So considering this, the distribution we have to do. Example, a student, let me consider, say for sodium. For sodium, the number of proton is 11, number of electron is also 11. So these electrons we have to distribute. It means what? We shall start reducing this 11 first by 2, then by 8, then again by whatever the left to next one, by that way. It means from this I shall first give the 2 to K cell. So subtract the 2, how much it become? Subtracting this 2, it becomes 9. So when this K cell is filled with 2, then I have to give for L cell. What is the maximum capacity? 8. 8 will go for L cell. Then taking the difference, we are left with 1. So this 1 will go to which cell? M cell. Okay, student. Here M is acting as, this is the outermost shell. Okay, it is like this one. Therefore, electronic configuration of this sodium, which is denoted by 11, means Na, with atomic number 11, which is written backside to this, is given by, for that you have to first write their cell number K. The K, it contains some electron, L also contains some electron, and M also contains some electron. So we shall put here 2 below this K, then 8 below this M with the comma, and whatever left 1 below this M. So this entire thing means this much thing you have to write. First you have to write this K element, and below that you have to write 281. It is the first example I have taken. A student, if I am considering, say, the nitrogen, For nitrogen, what is the serial number or atomic number we have learned? Student, it is 7. Okay. So for 7, you just start distributing. This 7 we want to distribute. First, if I give the 2, how much it will left? The 5. Means 2 I shall give this to K cell and 5 will go to L cell. So for this nitrogen 7, we shall write the electronic configuration like this. After this N, you write this N represents, student, the nitrogen. Okay, do not get confused with the N of our K element cell. Write the K and L. Okay, many a time this K and L are written at their top. Means this 7 can be distributed like 2 and 5. So after writing this 2 and 5, you write above this 2 as K and above this 5 as L. Are you getting? So this is the representation of electronic configuration. Okay, student, let me go for one more. Students, let us go for calcium. Calcium denoted as Ca. What is the atomic number or serial number, student? 20. This 20 means it contains 20 electrons. It's so simple thing. Now these 20 electrons have to be distributed. How I can distribute? First of all, I shall give the 2 to which cell? K cell. Then what will be the next one? 8 to L cell. This way the 10 is being exhausted. Means from this 20 I have reduced the 2 for this K cell. 18. Then 8 for this L cell. Then I will have the 10 electron. Okay. Then can I write the 10 here for M cell? Yes, student, can I write this 10 here for M cell? Means can I write like this? This as 2, 8, 10. Above this, we shall write like this. K for this 2, L and M. Can I write like this? Is it true or okay or not? Because M have how much capacity? M have the maximum capacity of 18. Here we are observing M have maximum capacity of 18. So that's why 10 can be put here. Is it correct to say? Yes, student, please tell me. Please understand this fact.
Yes, sir.
Why?
Because outermost capacity is 8.
Very good, excellent, student. This I was expecting from you. See, if I am considering writing M as 10 here, though the M have capacity of 18, but if this is the outermost, means the last one, then it can have maximum 8 only. Okay, no? So this way we have to understand whatever I am writing. If I am writing like this way, it becomes wrong. Why? Here M is outermost. The students. So here M as outermost. So once if it is considered as outermost, this implies it cannot contain more than 8. So what to do now, a student? So better to convert this. So first we need to.
We have to fill this with 8.
Very good. So first we need to fill this with the 8, and after this, whatever the electrons that will left, that have to go to the higher cell. Are you getting? It's so simple thing, student. So you have to understand this is the key of electronic configuration, or this is the application of the last rule. Okay. So we have to change this to 8, and after that 8, we need to give the remaining electron to the higher or the next cell. So student, this 10, if I am giving this to M cell, it become wrong. So what to do? Again, to avoid that M is acting as outermost cell, we shall put the 8 electron here and then we shall subtract, so that this M can have maximum 8 only. Okay? Then still it will left with the 2. So how we shall change it? Therefore, the correct is like, or the corrected electronic configuration is like this. So K, L, M, let us keep up to this much, 2 in K, 8 in L, and how much we shall now keep it here? 8 only. But how many electrons are total there? 20. Adding this to how much? 2 plus 8, 10 plus 8 is 18. But still we are
20.
2 more electron. So where this 2 more electron will go? 2 more electron will go to their next higher one. In their N cell. It's so simple. Are you getting? So this was the meaning of our octet rule. Getting it, students? So this is correct.
Yes.
Therefore, electronic configuration of calcium is our 2, 8, 8 and 2. Is it okay? So this thing we have to keep in mind, students. This was the application of our octet rule. We cannot keep 10 in M, because by keeping 10 in M, the octet rule gets violated. So this electronic configuration of calcium is very important and it is in your book. So this way you have to write the electronic configuration of every element. So filling we have done after giving the K2, L8, then we have gone to the other. It was this fourth, this we had applied. Then before this, for the calcium, what we had applied? This one. Okay. So this is applied in where? Potassium, which have 19, calcium, which have 20, etc. Okay, when 21, 22, all those things, it is also applied. So this was all about our today class. A student, after knowing this, you are able to write the electronic configuration, and how is this electron distribution I will explain tomorrow in this structure form. The K means this is the figure or picture form of representation of our electronic configuration. But the same electronic configuration in the number form is also written here. It is in your book. So this thing you have to keep in mind, and you have to do this electronic configuration in your home. Let me write the atomic number is enough for you. So this is your homework. You have to write the electronic configuration for each of these elements. Student, this is your homework.
If we should write.
Yeah, this is in your book, and these elements you have to write from your book, and above and ahead of this you have to write the electronic configuration. So this is the homework. Write electronic configuration for these elements. Students, here the atomic number is given, means number of electrons is same as that of the atomic number. So number of electrons present in hydrogen is 1. It simply means so electronic configuration. For that you have to write for, say for hydrogen you will write K. The K itself will contain 1. For this helium, if you want to write, for this helium it contains 2 electrons. So K, even 2 you have to write. If you are considering the lithium, then K can contain 2, but this is the 3, means one more is there. You have to put a comma, write the L and 1. These are the electronic configuration. For 4, the 2 we have to put in K. Then from this 4, 2 is already used, only 2 is left. This is the in L cell there will be 2 more. So it is this one. So these are the electronic configuration. So this way you have to write. You have to write the name of the element. Say you have to write like this: oxygen. You have to denote the element by O. Their atomic number you write in the back side as 8. Then write their distribution. 8 can be distributed with 2. Then 6. This 2 can be in K and 6 in L. It is the answer. This way you have to write for each element. You have to write the element number. Then you have to write the symbol and their electronic configuration. How is this distributed, or how this is represented in figure form or a structure form, that we will do tomorrow. Okay, student? So this was all about our today class. Any doubt, then please ask. Otherwise, we shall stop it here. Tomorrow we will learn about the neutron, the discovery of neutron, that we will learn, and after that we will draw the structure. So whatever this electronic configuration, everything remains unchanged. There is not any change. The only thing is that the neutron that was discovered in 1932 have to be put inside the nucleus. Rather than just putting P inside the nucleus, now we shall put P and N both inside the nucleus. Okay, students? No doubt? I hope so. Yeah, student, if any doubt, then you may please ask. Otherwise, we shall stop the class here.